Welcome to the first lesson in your 7th grade math class. Our first unit of study is going to be ratios, rates, and proportions. This is going to build on the content that you all saw as 6th graders. There are going to be a lot of skills that we're going to review here that you should already come into 7th grade knowing. But we're going to back up because we know that the end of last year was a little bit different for everybody. So we need to make sure that you understand the underpinning skills before we move on to 7th grade content. The first learning target that we are going to talk about is defining a proportion as a set of equivalent ratios. There are a few vocabulary terms that you need to be familiar with within your learning target. The first one is proportion. We're going to define that throughout this lesson. Equivalent. Equivalent is a word that you should come to us knowing, but if you don't, equivalent just means equal. So you could reread this as saying, I can define a proportion as a set of equal ratios. Now this word ratios is one that we're going to talk about throughout this lesson as well. A proportion is the equality of two ratios or rates. So a proportion is simply when you have two ratios that are equal to one another. There are two ways to determine if ratios are equal. One is a common scale factor, and the second is cross products. Cross products is more of a vocabulary term that we use in 7th grade, but in 6th grade, you may have been taught the butterfly method. This is one of the strategies that is used to help you understand cross multiplication. But to determine if two ratios form a proportion, these are the two ways that you will determine. Now, as long as you understand one way, that's fine. But there are two different ways to do that. Let's talk about this. It says equivalent ratios have the same value. Remember this word equivalent we already discussed is the same thing as the word equal. So we could say that equal ratios have the same value. Now, if you look at the three different things, I have 3 to 2 is equivalent or equal to 6 to 4. 1 to 3 is equivalent or equal to 9 to 27. And 5, 6 is equivalent to 35 over 42. Remember, there are three different ways to write a ratio. Here, we have a colon, 3 colon 2. The actual word 2, 1 to 3, and a fraction. Now, it already tells you that these are equivalent, but I want to test their equivalency. So the first thing that I'm going to do is I'm going to rewrite 3 to 2 as a fraction. So 3 over 2 is equal to 6 over 4. Now, I can put this equal sign here because it tells me that they're equivalent. The first method that was on the slide before says a common scale factor. Let me explain to you what that is. A scale factor is when you would multiply one thing to get to the other. For example, looking at the 3, what do I need to multiply this 3 by to get to 6? Your answer should have been 2. So if I multiply 3 times 2, it gives me 6. So the scale factor here is 2. Now come down here. What do I multiply the 2 by to get to 4? Is it the same scale factor? The answer is yes. So they have a common scale factor, therefore that these two ratios form a proportion. The other way that we discussed was cross products. Cross products, I told you, you may have heard it as the butterfly method. So let's discuss that. I have 3 over 2 is equal to 6 over 4. Now, with the butterfly method, I'm going to multiply across. So I am going to say 2 times 6. Well, 2 times 6 gives me a product of 12. All right. The next thing I'm going to do is multiply the other diagonal. So I have 3 times 4, and 3 times 4 is 12. 12 is equal to 12. Their cross products are equal to one another, therefore they are proportionate. Now remember, you don't have to test both of these. You can choose which method you like. Do you like to use scale factor? If so, use the first way I taught you. If you like cross products, use the second way that I taught you. I think you'll find that this one may come in handy when we talk about tables, but it doesn't matter. It's up to you. Let's talk about our second problem. Our second problem is 1 to 3 is equivalent to 9 to 27. So we have the ratio 1 over 3 is equal to 9 over 27. Now a couple of things I want you to notice here. First, this word equivalent allowed me to put this equal sign here. Okay? Now let's talk about the first way. Do I want to use common scale factor? If so, think, what do I multiply the 1 by to get to 9? Well, I got to multiply 1 times 9 to get to 9. And then come down here and say, well, I got to see if it's the same. So is 3 times 9 equal to 27? It is equal to 27. So we know that 1/3 and 9/27 are equal. They form a proportion. Now, for those students that like cross products or using the butterfly method, we have 1/3 is equal to 9 over 27. Let's use our butterfly method. So I'm going to say 3 times 9. 3 times 9 gives me a product of 27. 1 times 27 is 27. 27 is equal to 27. If the cross products are the same, we know that they form a proportion. The third one. The third, we have 5/6 is equal to 35 over 42. At this time, pause the video. You determine, what's the scale factor? Is it a common scale factor? Or you may want to use cross products. Decide, are these equivalent? Okay, hopefully you did determine that they were equivalent to one another. So 5/6 is equal to 35 over 42. Please remember, there are 3 different ways to write a ratio: colon, the word 2, and as a fraction. That is one of the questions on your quiz, so please make sure you remember that. A common scale factor, we've already kind of discussed it. So we have 4 over 5 is equal to 12 over 15. What I want you to notice is you're thinking about, how do I make this 4 into a 12 using multiplication? And of course you're going to say to multiply it by 3. So once you determine what your scale factor is, you need to go ahead and think, well, if I multiply the 5 by 3, will it give me the denominator of the other ratio? And it does. Both of these, and this is a little cut off here, both of these have a scale factor of a multiple of 3. And since they have the same scale factor, 4/5 and 12 over 15 form a proportion. We would say that they are equivalent to one another. cross products. Cross products, I want to walk you through this one. So we have 4/5 is equal to 12 over 15. Okay? Now, with cross products, remember it's also called the butterfly method. So I can multiply 4 times 15, and 4 times 15 is 60. 5 times 12 is 60. 60 is equal to 60. So we would say that these form a proportion. These two ratios form a proportion. All right, on this slide, we have one problem given to you in two different ways. We have the ratio 7/12 is equal to 42 over 72. So remember, you're asking yourself, what do I need to multiply this 7 by to get to 42? Hopefully you said 6. 7 times 6 is equal to 42. So I come down here and I think, well, if I multiply the 12 times 6, does it give me 72? And it does. So we could say that the ratio 7/12 is equal to the ratio 42 over 72. These two ratios are equivalent to one another. The other way of doing it would be cross products. Notice we have the same ratio 7/12 and 42 over 72. So I would do 12 times 42. 12 times 42 is going to be 504. And 7 times 72 is 504. And since these two are equal to one another, we would say that they are proportionate. Now, let's stop here for a second. You will never have a ratio that is proportionate in your common factor and is not proportionate in your butterfly method or cross products. That's why you can choose which one you want to do. It makes no difference to Ms. Banks or myself. Both are going to work every single time. A lot of students prefer this at the beginning, but as the unit progresses, they start to see it more clearly this way. Choose a way that works for you and stick with it. All right, so cross out all of the ratios that are not equivalent. So what I would like for you to do is pause the video, and I would like for you to answer which of these are equivalent or are not equivalent. All right, so let's go ahead and talk about some of these. You could have chosen to use scale factor, or you could have chosen to use the butterfly method. Either way is fine. Now, as we work through this, I want us to maybe go back and forth. So let's choose this one first. Let's talk about scale factor. What times 4 gives me 8? Hopefully you said times 2. 4 times 2 is 8. Well, is 9 times 2 16? Hopefully you said no. And if you did say no, that means that these do not have the same scale factor. I can't get to 16 from 9 using multiplication only. So we would mark this one out because it is not proportionate. The two ratios are not equivalent. Okay, let's look at this one. Let's say that I wanted to use the butterfly method or cross products. 2 times 9. 2 times 9 is 18. All right. And now I'm going to do 8 times 3. 8 times 3 is 24. 24 is not equal to 18. And that's how we show not equal. It's an equal sign with a line through it. So they're not equal. So 2/3 is not equal to 8/9. So we would say they're not equivalent. So I'm going to mark them out. All right. Now let's go to the next one. Here, 4. 4 times what gives me 12? Times 3. So let's look at the bottom. Is 5 times 3 15? It is. So these do form a proportion. So we wouldn't want to mark that one out. Let's go ahead and do the next one. Here, it's a little backwards. So what times 7 gives me 21? Notice that I automatically went to the smaller number because that's what I need with a scale factor, is I need to multiply the smaller number to get to the larger one. So I have 7 times 3 gives me 21. So now I'm going to do 11 times 3. Well, is 11 times 3 33? Yes, it is. So I'm going to say that that is also equivalent. I wouldn't want to mark that one out. Next, 5 and 60. Okay, what do I need to multiply times 5 to give me 60? Hopefully, you said 12. 12 times 60, or I'm sorry, 12 times 5 is equal to 60. Now next is going to be 8. Is 8 times 12 96? Yes, it's 96. So we would say that this forms a proportion. Now let's look at this one. We have 25 over 72 is equal to 13 over 24. Let's use cross products. Now, as I'm using cross products, some of you may be thinking, well, that doesn't make sense. Why would you use cross products when you can use scale factor? It's easier. That's fine. For those of you that do see this as using scale factor, perfect. That works for you. However, some students still need that butterfly method. They still want to use cross products, and that's okay. They can use it every single time. So I'm going to use 72 times 13. So 72 times 13 is going to give me a product of 936. Next, I'm going to do 25 times 24. 25 times 24 is going to be equal to 600. 936 is not equal to 600. Therefore, it's not equivalent. So I would mark this out. The next one. Here I have 19 times 5. 19 times 5 is 95. And 17 times 7. 17 times 7 is 119. These two are not equivalent. So therefore it is not going to form a proportion. So I'm going to mark those out. Here we can use scale factor if you want. We have 6, because I'm going to go to my smaller number. 6 times what gives me 18? So 6 times 3 gives me 18. And I would use times 3 down here. 11 times 3 is 33. That works out. So these are our 4 equivalent ratios. All right, so you try. 4 9s is equivalent. Remember, equivalent means equal to 8 over 18. Pause the video and answer the question. All right, so now let's do the work. We have 4 9s is equal to 8 over 18. It doesn't matter how you want to do it. I'm probably going to do scale factor. What number times 4 gives me 8? It's times 2. Come down here. 9 times 2, does it give me 18? Yes, therefore it's true. If you wanted to use scale factor, 4 9s is equal to 8 over 18. Think about it. What number would I multiply the 9 by? Good. 8. So 9 times 8 is equal to 72. And 4 times 18 is equal to 72. These two are the same number, so it's still going to be true. They are proportionate. These are equivalent to one another. The next one, 5/9 is equal to 30 over 54. Is that true or false? Pause the video and answer the question. Okay, so let's go ahead and do the math here. We have 9 times 30. 9 times 30 is 270. And 5 times 54 is going to be 270. These two are the same. Therefore, it is true. They are equivalent. You can also use scale factor. 5/9. 30 over 54. Sorry. What times 5 gives you 30? Times 6. Well, let's come down here. Times 6. Is 9 times 6 54? Yes, it is. Therefore, it's true. Now let's talk about when you're given 3. What we want to do is we want to test the first two. Then we can pick one of these and test the third one. So I have 18 over 12 is equal to 9 over 6. This is a very good problem because think about it. Here is our first time that we have a smaller denominator than numerator. It doesn't matter. We're going to do it using the same method that I've already taught you. Go to your smaller number. What times 9 gives you 18? Well, times 2. So come down here. Times 2. Is 6 times 2 12? Yes, it is. So we know that these two form a proportion. They are equivalent to one another. Now, what about this one? It doesn't matter which one you want to use. I want to use the 9/6 just because they're smaller numbers. So 9/6 is equal to 36 over 24. Okay? Now, you can use scale factor if you want. I'm going to use cross products for those students that are using cross products. So here we have 36 times 6, and that's going to be 216. All right. The next is 24 times 9. So 24 times 9 is 216. These two are equivalent to one another. So I know that this one and this one are equal. Only have one more to do, and that's these two on the end. 18 over 12 is equal to 36 over 24. Now, I would use scale factor here just because it makes sense. All right, so I'm going to look at this and say, what times 12 gives me 24? And that's times 2. All right, 12 times 2 gives me 24. So I'm going to come up here and I'm going to do 18 times 2, and that's going to be equal to 36. So I know that 18 over 12 and 36 over 24 are equal as well. So true, they are equivalent to one another. Here, 2 over 24 is equivalent to 10 over 120, which is equivalent to 4 over 480. Pause the video and see if you get it right. Okay, now let's look at this. We have 2 over 24 and 10 over 120. A couple of different ways you could do this one. First, I see you could do probably cross products if you wanted. So 24 times 10. 24 times 10 is 240. And 2 times 120 is going to be 240. So these two are equal. Alright, so we know that these two work. Now let's do these. We have 2 over 24 is equal to 40 over 480. We could do cross products on this one. So I have 2 times 480, and that's going to be 960. Next, I have 24 times 40. So 24 times 40 is going to be 960. These two are equal, so I know that this one is equal to that one. The last two to check is these. So we have 10 over 120 is equal to 40 over 480. So the first one that I'm going to do, you can use the scale factor if you want. What times 10 gives you 40? Well, that'll be times 4. And then when I come down here, 120 times 4 is going to be 480. So those two work. So I know that 10 over 20 is equal to 40 over 80. Okay, and that's true. So these three ratios, because remember, this is a ratio, this is a ratio, and that's a ratio. These three ratios are equivalent. And remember, this word equivalent just means equal. Right, next one. We have 1/7. Oh, and this one's kind of messed up. Let me move it over here where it belongs. And 10 over 70. And here, I like this question because it's written in 3 different ways. When I started the lesson, I told you to remember that ratios can be written in 3 ways. Here you have the colon, the fraction, and the word 2. So what I'm going to do here is scale factor. What times 1 gives you 10? Times 10. Go down here, multiply this by 10. 7 times 10 is 70, so these two work. I'm going to do 1 over 7 again, and let's try 5 over 65. Alright, so what times 1 gives you 5? And that's times 5. Then I come down here and I'm going to do 7 times 5, and 7 times 5 is that 65? No, it is not 65. In fact, it's 35. So when this does not work, here, our scale factor did not work. This is false. They are not equivalent to one another. So it would be false. The next thing that I want us to talk about is determining proportionality given tables, and this is very difficult for some students. I do want us to take our time here. I want us to think about the question. I want us to think about how we know the answer to the question. So, how would you determine if the table showed proportionality? Remember, proportionality is a very fancy way of saying 1/50th, because that's a ratio, meaning in 1 hour you drove 50 miles. The next ratio is 2 hours, 100 miles, 3 hours, 150 miles, 4 hours, 250 miles. So we got to determine, are all of these ratios proportional to one another? That's our goal. That's what we have to determine. So what we need to do is we need to take a look at this, and we have 2 ways. Looking for a piece of paper, sorry. We have 2 ways we can do this, all right? Butterfly method, cross products, or you can use scale factor. It's up to you. So we're going to take 1 over 50, 2 over 100. All right, so notice I've taken the first ratio and the second ratio. So what I want to do is I want to multiply. You can do cross products. That's what I want to do first. 50 times 2. Well, 50 times 2 is 100. And then 1 times 100 is 100. These two are equal to one another. Therefore, these two are proportionate. All right? So what I'm going to do is I want to stick with 1 over 50 just because these are smaller numbers. 3 over 150. Now for this one, I can use scale factor. I can use butterfly method if I wanted. 50 times 3 is 150. 1 times 150 is 150. These two are equivalent, so I know that 1 over 50 is equal to 3 over 150. I'm going to stop here just for a second because a lot of students will get confused here. They'll want to say, well, 100 isn't equal to 150. But you have to understand these are two completely different questions. Here, we're determining if 1 over 50 is equal to 2 over 100. For this one, we're determining if 1 over 50 is equal to 3 over 150, which they are. Okay? Next, I'm going to stick with 1 over 50. And the last one is 4 over 250. Now, you can use butterfly method if you wanted. You can do 50 times 4. And you can do 1 times 250. Well, 50 times 4 is going to be 200. And 1 times 250 is 250. Now, does 1 over 50 equal 4 over 250? No, it doesn't. And since these two numbers are not equal to one another, there's no proportionality. Even though this one connects with this one as proportionate, and this one connects with this one does not, or is not proportional to the last one. And you only need one that is not proportional for this whole table to not be proportionate. So the answer to our question, how could we determine if the table showed proportionality? The first answer could have been cross products. The second could have been scale factor or common scale factor. Now it says you and your group brainstormed some ideas how we could determine proportionality. We talked through this, okay? So we know that this table is not proportionate because we did the work and the ratios, even though the first three are, the fourth one is not, okay? So we have 4 hours, 250 miles is not proportionate to 50 miles per hour. Now, we're talking about your group's ideas. When we were going to do this face-to-face, we like to have discussions with you and your group. However, with this problem, I want you to look at it and make sure you can read the table. What I would like for us to understand is here, the units for these numbers on top is hours. The units for these numbers on the bottom is miles. So you drove 50 miles in 1 hour. You drove 100 miles in 2 hours. You drove 150 miles in 3 hours. Okay? That's what I'd like for you to get from this slide. What conclusion can you make about the relationship between the number of miles walked and the time spent walking. You have three options. The table does show proportionality. The table does not show proportionality. Or C, there isn't enough information in the table to determine proportionality. So what I would like for us to do, pause the video, answer the question, and we'll come back and discuss it. Okay, it's okay. Here we have 1 ratio, 2, 3, 4, 5 different ratios here that we're going to work with. All right. So the first one, we have 1 over 1.5 is equal to 2 over 3. Let's use our butterfly method. We have 1 times 3 equals 3. 1.5 times 2 equals 3. These two numbers are the same, therefore these first two ratios are equivalent. Now I'm going to keep the first one because that's the smaller number. Okay, the first thing I want to do is 1 times 4.5, and that's going to be 4.5, or 4 5/10. The next is 1.5 times 3. 1.5 times 3 is 4.5, or 4 5/10. These two numbers, or products, are equal to one another. So we know that 1 over 1.5 and 3 hours and 4.5 miles are equivalent, or equal. The next one is 1 over 1.5 is equal to 4 over 6. So I'm going to do 1 times 6. 1 times 6 gives me a product of 6. And 1.5 times 4 gives me a product of 6. So that means 1 hour and 1.5 miles is equivalent to 4 hours and 6 miles. So we know that that's equivalent. Remember, students are going to want to get caught up. 6 isn't equal to 4.5. Well, remember, we're talking about different ratios with each of these. Last one. 1 over 1.5. Let me rewrite. 1 over 1.5, or 1 5/10, is equal to 5 7.5, or 7 5/10. So the first thing I'm going to do is 1 times 7 5/10 is going to be 7 5/10. The next one is 1 5/10 times 5, which is going to be 7 5/10, or 7.5. Sorry. Since these are equal, that means that the first ratio is equal to the last one. And if all of them are equal, then the answer has to be, it does show a proportionality. Each one of these ratios are equal to one another, therefore they show proportionality. Alright, so now what I would like for you to do is I would like for you to go ahead and pause the video, answer these next 3 questions. So this will be first, this is second, and this is third. Okay, let's go ahead and look at these. For the first one, you should have gotten true. This table shows proportionality because for every adult ticket that's sold, it costs $75. For the second one, you should have gotten that this one is false. The first thing you could have seen is that if you did cross products, 1 times 1 is 1, but 0 times 3 is 0, and 1 is not equal to 0, so it would be false. For the third one, we really haven't done a table like this, so I want to walk us through what that would actually be. So for this one, I could see where students could be a little bit confused because you may have wanted to do 5 over 10, but in reality it should be 5 over 2 because that's the way the table is set up. So we have 5 over 2 is equal to 10 over 4. Okay, so what you can do here is you can say, well, 5 times 2 is 10, and 2 times 2 is 4, so that works. So you know that these two work. I want to keep the 5 over 2, and I've got 15 over 6. Well, what number times 5 gives you 15? That's times 3. Come down here and do times 3. Is 2 times 3, 6. Yes, so it's continuing to work. Notice I'm keeping the first ratio, and the only reason that I do that is usually they're smaller numbers and they're easier to think of mathematically. So I have 5 over 2, and the next one is 20 over 8. So I'm going to do 5 times what gives me 20? 5 times 4. Come down here and write times 4. 2 times 4 is 8. So our scale factor works still. So this one works. So we have 5 over 2 and 25 over 10. What times 5 gives you 25? It's times 5. Go down here, times 5. So 2 times 5 is 10. So we know that all 5 of these ratios are equivalent. Therefore, they show proportionality. So your answer should be true. Guys, this is it for the first learning target. Hopefully, you understand what it is that proportionality means, what a ratio is, what equivalency means within a table or within a ratio. Remember, a ratio can be written in 3 different ways. You have a colon, you have a fraction, you have the word 2, just like this, the 3 different ways to write a ratio. All right, please remember, if you have any questions at all, do not hesitate to email Ms. Banks or myself.